Let's look at the idea of ecosystem-based adaptation. I like this because I think many countries, especially countries with long coastlines like India, which are vulnerable to climate change with the high climate risk index, for example, have degraded their natural defenses along the coast, like mangrove forests, coral reefs, wetlands, which can be recovered, and the so-called blue carbon in the coastal waters can actually sequester much more carbon than forests on land, and India has committed to generating additional carbon sinks with afforestation, but instead, if in addition, if it went for blue carbon solutions as natural defenses, then the co-benefits are going to be massive. So, ecosystem-based management options are considered typically in fisheries, where instead of catching just one fish that you are interested in, you look at its position in the ecosystem in which it lives, so that you don't fish down the food web as we discussed before, and you manage the whole ecosystem as a unit. Easier said than done, but it's a very good concept, and hopefully very practical solutions will evolve. In the context of adaptation, also we can think about the ecosystem-based adaptation. Basically they use capacity of the nature to buffer human systems from adverse impacts of climate change. So without ecosystem-based adaptation, climate change may cause degradation of ecological processes which are presented here, leading to losses of human well-being. But implementing the ecosystem-based management shown in these boxes, which I will discuss in a minute, could reduce or offset these adverse impacts, resulting in a virtuous cycle that reduces climate-related risks to human communities and also has potentially has additional mitigation benefits, or what we can call co-benefits. So the blue box here is ecosystem-based adaptation, and the gray arrows here correspond to without ecosystem-based adaptation. So if you think about climate change impacts coming on degradation of ecological processes, loss of biodiversity, and so on, which have already been observed in around the whole world, as we saw in the impacts map from IPCC, a synthesis of studies of physical systems, biological systems, and human and managed systems, if you remember. So loss of ecosystem services, so could be fisheries, could be food, fiber, and medicine from forests, could be agricultural production, and so on, which leads to loss of human well-being, which can be a metric easily defined, and there are many metrics, which would increase pressure on ecosystems and natural capital, as they are called, and that would exacerbate the original climate impact. So this is something we want to avoid by doing ecosystem-based adaptation, where we look for ecosystem protection and restoration in response to climate change impacts, or just human impacts directly, like land use change, not through emissions and climate change necessarily. That leads to biodiversity retention, ecosystem resilience, so how quickly it can recover from shocks, and reduced vulnerability. For example, if you are fishing for anchovies in the eastern Pacific, during El Nino the upwelling is reduced and anchovies are going to face difficulty anyways. If you put up fishing pressure during an El Nino, then you can drive a collapse. So similar things can happen under climate change, where your activity is somehow affecting adversely affecting ecosystem, and climate change is going to just increase vulnerability, but ecosystem-based management can reduce those kinds of vulnerabilities. Sustained ecosystem services delivery can result from that. increase in human well-being, of course, and sustainable economies with reduced risk of climate impacts, leading to better ecosystem production and restoration, as well as co-benefits of climate mitigation. For example, the mangrove forests can improve habitats, oxygen, nutrient filtration, lots of income from fishing in those grounds, carbon sequestration, protection against cyclones and storm surges, and so on. Okay, so implementation is, as I said, not always easy, but nonetheless very important concept. So this is a way of looking at economic costs and feasibility, again in a heuristic sense. It's looking at two situations where one has full adaptation possible, the other where some unavoidable climate risk exists. So it's looking at adaptation cost versus cost of climate change, and this also means avoided impact. So the higher the cost of climate, the less you are spending on adaptation, so you are just suffering from climate change impacts. You are not avoiding them at all. So on this space, you have this curve which increases adaptation cost as you want to avoid more and more impacts. And if you spend enough, you can potentially avoid all impacts in a specific context for a specific region and so on. But nonetheless, heuristically, you know what it means, and you can choose optimal balance between adaptation costs and residual impacts, which means you adapt to deal with the impacts, but you are going to leave behind some because you don't want to spend a lot to completely remove all the impacts. Okay, so this is kind of tolerable risk kind of situation where you have optimized your financial resources and reducing or avoiding climate change impacts. Whereas in the case where full adaptation is not possible, you are going to not going to hit the zero impacts on this axis. So you're going to have costs that cannot be avoided by adaptation. So the same phase space, but now you look at cost of climate change with suboptimal balance with imperfection. So what we will do, that's shown in the next figure that in the previous figure that I'm not showing here. Optimal balance, what we want to do, so what we will do versus what we want to do, and then there are technology limitations in terms of what we can do. Okay, so you can see here you have avoided impacts on this side in these gray arrows. So the more you spend in terms of adaptation cost, more are the avoided impacts, and there are residual impacts which are higher when you spend less, and that's what you are willing to do, or what you want to do can increase the cost but have fewer residual impacts, and the adaptation costs are shown on this horizontal yellow line. Okay, these are some examples of actors' adaptation objectives and adaptation options, real or perceived trade-offs, and the studies that report those. I won't go through the whole table. There are long tables of these in the IPCC report in the previous assessment, and there are going to be similarly many in the upcoming CMIP 6 AR6 assessment coming out this year in 2021. Got delayed probably because of COVID, so we will see when it will actually come out. So let's just look at agriculture for example. Actors' adaptation objective is to enhance drought and pest resistance and enhance yields, and provide financial safety net for farmers to ensure continuation of farming enterprises, and maintain or enhance crop yields, suppress opportunistic agricultural pests and invasive species, which are all outcomes of climate change impacts. And adaptation options include biotechnology, GMOs, subsidized drought assistance, crop insurance, increased use of chemical fertilizer and pesticides. Of course, these have side effects that are unintended or not desirable. So real and perceived trade-off then include perceived risk to public health from GMO, for example, and safety, ecological risks and associated with introduction of new genetic variants into the natural environment, creating moral hazard and distribution inequities if not properly administered in terms of the crop insurance and subsidized drought assistance. In increasing chemical fertilizer unit use and pesticides, you would increase discharge of nutrients and chemical pollutants to the environment, groundwater, river, coastal waters, and so on, drive harmful algal blooms. Adverse impacts of pesticide use on non-target species like other birds, pollinators, etc. Increased emission of greenhouse gases, of course. Agriculture is a significant contributor already. Increased human exposure to pollutants, and there are various studies arguing about pesticide impacts on human health. So there are similar examples in other areas like biodiversity, coasts, water resource management, etc. that I won't go into. Okay, so let's close this here and come back to what Paris Agreement is all about and so on in terms of their implications for adaptation, which is the goal, which is the main subject of this particular chapter.